About 13.75 billion years ago, our universe, as we know it today, was created. Shortly thereafter, the primordial light began to shoot through the cosmos and spread throughout the entire early universe. At this time, the universe itself also expanded. However, the inflation of the universe slowed down after the first initial eruption, but since then, the rate of expansion has been steadily increasing due to the influence of increasing dark energy. In essence, the cosmos has been growing at an ever-increasing rate since its creation. Physicists and mathematicians have been studying the nature of the universe for hundreds of years, trying to solve the mysteries it contains. But there are some scientists who go one step further into the unknown by thinking about what lies beyond the boundaries of our universe. Is it possible that there is something else beyond the existence of our own universe? Other universes, worlds whose existences we can only guess at? That could well be the case. Here are 5 theories about what this something could be and what clues there are for the various theories. Hubble volume. The notion of outside the universe is very tricky because first, the universe has to be defined more precisely. A common formulation which does more justice to the core of the matter is the term the observable universe, whereby the speed of light plays a major role here. Since we can only see things when the light that they emit or reflect reaches us, we can never see further than the greatest distance that light can travel in the time that the universe has existed. Cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light-years since the Big Bang. This means that the observable universe is about 93 billion light-years large, plus or minus a few light-years. These approximately 93 billion light-years contain all the quarks, quasars, stars, planets, nebulae, black holes ever recorded by a telescope, and everything else that we might be able to observe but have not yet seen. But the observable universe contains only the light that has had time to reach us. This also means that the observable universe is getting bigger and bigger. However, the universe is also finite. The limited amount is also called the Hubble volume, after the telescope that has given us the most distant views of the universe so far. We will never be able to see beyond this limit, so it's basically the only universe with which we can ever interact. However, we know, with a probability bordering on certainty, that there is more universe beyond that limit. Astronomers believe that space invisible to us could also be infinite, with matter, energy, galaxies, etc., distributed pretty much exactly as in the observable universe. Beyond the Hubble volume, we will not only find more planets, but also other planets very similar to our Earth. If we go far enough, we will find another solar system with an Earth that is identical in every respect, where you had cereal for breakfast this morning instead of eggs, and another world where you skipped breakfast, and yet another world in which you got up in the morning and then robbed a bank. In fact, cosmologists believe that if you go far enough beyond the boundaries of the universe, you will find another Hubble volume that is completely identical to ours. And in those other Hubble volumes, there is another version of you out there that reflects every possible action you might take. This may seem unlikely, but then again, the infinity of the universe is very hard to imagine because it's simply beyond human imagination. To break this down, according to the theory of relativity, objects that are close together cannot move against each other faster than the speed of light. However, there is no such law for objects that are extremely far apart when the space between them expands. In short, it's not that objects move faster than the speed of light, but that the space between the objects expands, causing them to fly away from each other at amazing speeds. Ultimately, this means that we could only reach the edge of the observable universe if we developed a transport method that would allow us to either 1. Travel faster than the speed of light, a theory that most physicists believe to be impossible, or 2. Transcend space-time by wormholes or warp propulsion, which most physicists also believe to be impossible. Dark flow. In 2008, astronomers discovered something very strange that they had not expected. Galactic clusters were streaming in the same direction at immense speeds, over 2 million miles per hour. New observations in 2010 confirmed this phenomenon, known as dark flow. Scientists discovered the phenomenon by studying some of the largest structures in the cosmos, giant galaxy clusters. These clusters are collections of about 1,000 galaxies and very hot gas that emits X-rays. By observing the interaction of X-rays with cosmic microwave radiation, or CMB, left over from the Big Bang, scientists can study the motion of clusters of galaxies. The X-rays scatter photons into the cosmic microwave background and shift the temperature in an effect known as the Sunyaev-Zeldovich kinetic effect. This effect had not been previously observed as a consequence of clusters of galaxies, but was first noticed by a research team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center, when it examined about 700 clusters that were up to 6 billion light-years away, halfway across the universe. They compared these clusters with the map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe, WMAP satellite. The motion of the clusters defies all predictions about the distribution of mass in the universe after the Big Bang. One possible cause? Massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of the suction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our point of view. As for the structures themselves, they could literally be anything, from accumulations of matter and energy on almost unimaginable scales, to bizarre fault lines that conduct gravitational forces from other universes. Infinity bubbles. Talking about things outside the Hubble volume may be misleading because it is still the same universe, only part of it we cannot see. The same physical laws and constants apply. In another version of the story, the expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding together with the rest of space and formed its own universe, with its own laws and physical constants. In this scenario, space is infinite, and each bubble for itself is also infinite, because a single infinity can contain an infinite number of infinities. Even if you could somehow break through the boundary of one bubble, the space between the bubbles would still expand, so you would never reach the next bubble, no matter how fast you move. Black holes. A theory proposed by physicist Lee Smolin, known as the theory of fertile universes, states that every black hole in our universe causes the creation of a new universe. Each universe will have slightly different physical laws than the previous one. In this way, Smolin suggests a kind of natural selection for universes, since laws and physical conditions that lead to the frequent formation of black holes are also the reason for the formation of other universes, while universes that do not form black holes become extinct. The theory has since been disproved by Smolin himself and others. An infinite number of parallel universes. There are innumerable theories about parallel universes, but the most valid theory today involves a further development of the ideas of string theory. This involves so-called membranes that oscillate in different directions. It is beyond the scope of this video to go into too much detail about string or membrane theory, but the essence of the theory is that the rippling membranes beyond the worlds in the 11th dimension are completely different universes. And when the waves collide, a new universe is created. The effects of wave motion help to explain the observed distribution of matter in our universe. One of the strangest elements of the theory is the idea that all the gravity we experience in our universe actually comes from another universe in another dimension, which explains why gravity here seems so weak compared to the other fundamental forces. What do you think? Are there other unknown worlds outside our universe? Does infinity exist? And if so, how infinite is it? Parallel universes, warping matter, string theory, membranes and black holes. Do you think it's all just hogwash? Or is there really something to it? Let us know what you think in the comments.